As we were moving forward into lecture 3, we're speaking about how different species can be found or variations of species in different areas, such as continents and islands. So, in this case, we had a list about how different variations of these species would be looking like in different areas, such as New Zealand or some of these Mediterranean islands where we had either much bigger or smaller pygmies or dwarfs or other kinds of formations of these species present in certain areas. Now, we had this list again, including things like being threatened by extinction. There were at least 6 of these different peculiarities, some of these special features of species living on islands. Beyond that, the main point of lecture number 3 was speaking about how these new species would be forming, and that was about what we would call allopatric speciation. So allopatric speciation is going to be the process that would be naturally occurring, and it's based on only 2 things: a barrier and a natural variation in the genetic pool of certain species or populations of species. So what we need to think of in the first place is if we have some kinds of like animals, they would be somehow similar in many ways, but there will be some differences between them. Some have bigger heads, shorter legs, others would have longer necks. Whatever these differences would be like. So there will be natural variation in the kind of like genetic differences which would like randomly occur. And what would happen is that some of these individuals of a population could be crossing some kind of barrier, borderline between the populations. And what can this be then? So what is this kind of barrier? Where in the case of islands, we said, so away from continents, it would often be something like water. So I just put here waves. What this is, some like an ocean. This is not very nice, but this would represent the sea and how waves would divide this. So in some ways, you can say that different individuals could be crossing this barrier, which we said would, in this case, often be a body of water. And what would happen is that depending on the actual peculiarities of these individuals, perhaps they would have bigger heads. So in the future, this new population that would develop here will mean that these new individuals that will be offspring of these members of the original population would be developing different ways just by the random genetic differences that they would originally have. Often, of course, we can say that it's just a random set of individuals that would be crossing the barrier, and in this case it's a kind of like mutation, naturally occurring mutation that would cause the development of this species further into something else, something new. And in this case, at the end of the day, we might say that this is actually not going to be anymore part of the original species, but it will develop into something that in its genetic set or in terms of genetics would be meaning that they are not going to be able to interbreed anymore, so they will not be able to have fertile offspring, so they cannot be by definition in any ways be called the same species. Perhaps we can say that they could be breeding, but just by, say, nature, they will not be able to meet anymore because of this barrier. So in that case, you can also think that they will be, in a way, different species if they also behave in different ways. So in this case, there's a limit or borderline between species, what belong together, what do not belong together, which is kind of blurred. We don't want to go more into details in that one. But just to think of like the geography here, so if this is the barrier, what else can be a barrier? It's not only a body of water such as an ocean, but it can be something like, say, a river. So a river can be something that maybe in the past some of these individuals were able to cross, but due to climate change, perhaps maybe a historical climate change and more precipitation in the area means that the river would develop in its size, would be wider and would not be able to be crossed by some of these original populations that were on one side. So river can be a barrier. Also, we can think about mountains, so mountain range. Just put here mountains. But there can be other like factors here. Volcanic activity. We can also think here like extreme events like flooding or things like related to geomorphology or the development of the surface. And what else can be some of those like more human induced barriers or developed barriers, such as like roads. So just by constructing a highway or a high-speed rail track across an area, that would not be able to be crossed by these animals. That would create a kind of barrier between populations, and later on probably this can happen in hundreds and thousands of years in time, that these populations would never mix again and then can develop into like new species. So just some examples that we can think here of how this happens. So the point is that members of an original population would cross a barrier and further develop into something else. Now, beyond the allopatric speciation, there was another process which we were discussing in this lecture 3, and that would be adaptive radiation. So adaptive radiation, again, allopatric speciation, they are relatively difficult to remember, I think. I don't really have anything else to tell you here how to tie or what to tie these words to, so you should just remember allopatric speciation and adaptive radiation. Might sound quite strange to your ears. So adaptive radiation will not be about this natural, purely like physical and genetic or biological activity in nature, but also behavior. So this is about how animals behave. And then we could say that there was this kind of example how like birds with different beak sizes or deep beak depths would be able to mate. So just by thinking of how their beaks look, how big the beaks are, they will have a different kind of song, different kinds of sounds, and the mating partner of these birds, just by thinking of what the sound of their songs are like, based on the shape and size of the beak, they will be starting to develop in different ways. So there will be some perhaps have these curvy beaks, other will have longer peaky beaks, and this is purely then based on their sound that would naturally be given. Obviously, this will be also related to what kind of resources they feed on, so whether they consume seeds or insects. Also, it will be related to how they would be mating later on, so how these individual like features of specific individuals, so how these would be carried to future generations and develop further into something that we would call later on being part of different species. So that is again about the behavior of the animals, how they further develop these possible differences that would be just simply originally a kind of result of the allopatric speciation. So that's why we can say allopatric speciation is a first step in the development of species. And once there will be some possible slightly different populations within a species, so these would be further on enhanced, these differences would be further developed thanks to adaptive radiation, which is simply about the behavior of animals.